Hello to all participants. Basically, I'm going to talk about the battery design for vehicle integration, and also we'll talk about techniques and technology and all the challenges of battery design. Probably would be the ideas to create your model. Basically, the battery is in different form. So we talk about the bike. What is the main point? If it's hybrid. So what does it mean? You need to rotate the speed, and that could produce the energy. So if it's top speed, so basically the motorcycle is the hand accelerator, which is the same with the motorcycle. E-car, e-truck and bus and boat are the same. They use the battery pack motor controller motor gear. The gear depends on the type of vehicles. The wheels usually is at the back of the vehicles. Basically, EV feature has many types. Right now is BEV, use the energy from the battery alone. The series parallel, as it appeared in for Toyota vehicles. The electricity circuits. Grid is AC. Basically, EV is installed on-board charger. The battery is charged through DC only, not AC for charging battery. So the charger needs to the quick charging.
These are the chart and the model for the charging system within the car, within the vehicle itself. So how did transfer from grid to normal charging or quick charging into drive battery charging and inverter, and move to motor electricity generation through the transmission, through the wheel and generate braking. If its battery for the normal car is 12 volt, if it trucks or bus, it will be 24 volt. Because of the trucks or the buses, it's quite a big vehicle, so it is necessary to have a high power and high voltage. It is very difficult to replace the lithium battery for 12-volt battery because of the lithium battery are quite expensive. Before, when we don't use the vehicle for a while, the battery will run out. But now, even though if we made or produce the electrical vehicle with 12 volt, it is the same concept. We have to recharge the battery now and again, quite frequently. Maybe to turn on and to turn off the battery pack. Now we're talking about the electric motorcycle. We use hub motor for electric motorcycle, which is not very complex. With the mid drive motor for electric motorcycle, if we use the infused motor, the power is not enough for the motorcycle to drive up to the hill or to the incline hill. With the charging for the electronic motorcycle, at the moment we use battery installed in motorcycle. There's wired and wireless, also with the battery swapping. At the moment we're trying to develop the battery swapping platform. At the moment, work together with the government department and other organizations that work together. With the battery swapping, we can use and charge at home. There are also public battery swapping for rent.
This is one way of the EV conversion. There remains some part of ICE platform. To save the supply chain. The high voltage cost, the cost is pretty high. If you use two motors, low gear and other system or other drive system, finding the size of EV and power calculation. How do we know the size of battery? We need to know the specification of that vehicle model. We use that specification to calculate the power of battery. So we need to consider the gear, the powertrain, to design the battery pack. This slide is the World Motorcycle Test Cycle. There are 3 levels. First, Thailand probably don't care about because it's not 60 km per hour. The second one, if Honda Wave is in the market level, WMCT is the big bike test drive. In Thailand, we cannot use the low speed on the road because it cannot even pass over the bus. I cannot make a U-turn. In the right hand is the driving circle for sedan or pickup. There are 2 types, NSTDA. If it's new one, it's WLTC. This one on the left hand, we calculate by knowing the motorcycle specification. We can calculate the power. The highest power for MWT C2, it occurs from the from accelerating the speed 80 km per hour and maintain about 80 km per hour. The peak of power, if the speed maintained, the speed would be low. The peak average is important to find the model. The loading of battery is to indicate So this graph is about driving circle. The speed depends on the time. The below is to calculate the power depending on the model of the model as a sample of power calculation. The power peak occur not in the high speed but accelerating. For example, from 0 to 80 km/h. The motor drives is the power that the battery can generate. This vehicle, the power can indicate the area under the graph, depends on the time. DT will get the battery loaded. How to calculate the power is from this. So it's from rolling resistance, aerodynamic resistance, or the grade resistance, or the initial resistance. Let's say if it's grade distance and rolling distance is pretty high, If it's high speed, the aerodynamic is high as well. This term dominates when the acceleration is required. If you want, you can lower the weight of the vehicle. The body of the vehicle needs to be aluminum to lower the weight of the battery. The drive power is the calculation of all resistance. The motor power is 2 pi Tn. They are all equal, but it's not included. The motor power use this, battery power use this.
This slide shows you how to communicate between the power of the driving cycles. You can see the graph shows here. The software has been validated with the NSTDA website. But this information will be for public use through the Microsoft Excel on NSTDA website only. Now we will look at the benefits of the power supply. Here are the differences between the battery and the power supply. The power supply is on 12 volt. However, on the other hand, with the battery, the level of battery will decrease slowly and slowly. However, it depends on the company that made the battery as well. Here are the different types of battery. With the Li-ion battery, mostly used, the battery will be NMC. However, the most effective one and the safest one will be the LTO lithium titanate. But in Thailand, we use NMC and LFP. Now, here are the differences between the NMC and the LFP. Here is the difference between those two. With the LFP, there's a capability to charge faster and more safer than the NMC. Whereas the NMC has a longer lifetime capacity for the battery. With the NMC, the battery can increase to 4.2 volt, whereas the LFP is only 3.6 volt. The LFP battery is quite difficult to detect the power. For example, if the car driving on 200 kilometers, the NMC will calculate the time to show how many batteries left, whereas the LFP battery is more accurate in order to calculate the distance. Here are the shape of different type of battery. Mostly there's four shapes, but at present I only show 3 at the moment. The first one is cylindrical, second is pouch, and thirdly is prismatic. These three shapes are used differently. For example, BMW we use prismatic, and for Nissan we use pouch. Here are the foundation when we choose different type of battery. Well, the battery doesn't like to stay in the heat, so the temperature need to be not too high, maybe 40 to 50 Celsius. Also, the discharge characteristic also is a concern. You have to look into this as well. Now we look at the voltage and the C rate. The voltage divided into 3 parts: maximum voltage, nominal voltage, and cutoff voltage. Maximum voltage meaning that the battery are fully charged. Cutoff voltage meaning that the battery is at a very low level. Normally, the 12-volt battery, when it's fully charged, it will be up to about 13.6 volt. And the battery will be run out at 10.8 volt. Now we look at the C rate. Well, the size of battery, for example, 60R 1C, which means we consume 60 amp. The battery will last 1 hour. For 2C or 120 amp, the battery will last 0.5 hour. And for 0.5C battery, 30 amp, it will last 2 hours. State of charge. When we talk about state of charge or SOC, what it means, it's the level or the gauge to show the level of the battery between 0% to 100% battery. The chart shows the different type of battery and the percentage. Now we move to the motor controller or inverter. we have to choose the correct DC and DC. We have to choose between input DC to the output AC. For example, if the motor controller between 40 volt to 90 volt, we have to choose the battery pack accordingly. Because if you don't choose the battery pack and the motor controller, if you don't calculate it appropriately, then it can cause damage to the motor controller or inverter. So you have to consider between the U max and U min as well. This is a very important slide here that I show.
If you want 480, there would be 3 types, 3 platforms. Charge 60 ampere hour, 20 amp hour per grid. The third type is for 20 amp hour. The first one, disadvantage, pros and cons. So we bring the big battery to the grid, so BMS, connect with the grid. We need the BMS component. If we connect with the grid, BMS needs to be installed. The pros: it's cheap, pack, but this is the con. If any of grid dead, it doesn't work, doesn't function. But it's the safest, but it's used for the big vehicles only. The second one is the module section, the grid connection. You lose the third fuse. The master would waste a lot of BMS, but if this fuse, if we lost one fuse, the proportion will not lost because the voltage is still enough, but the capacity would be decreased. The popular
With the third type, parallel or serial connection, it's used by Tesla Model's car. As you can see, the one BMS, there's one current sensor. with the Tesla company use parallel or serial connection. So this is more safe by using many fuses.
Eventually, the voltage, if the battery was dead, just one, it's still able to propel, but the performance of the battery would be low. The type of battery pack, if we talk about the same power, the low voltage and high voltage, what does it mean? If we choose the low voltage, we need to use high electricity to propel. Normally, if it's not over 60 volts, this voltage cannot pass through human body. The capacity would be lower, can be electrocuted. If you use the low voltage with the big system, the electricity would be high. We need to decrease the heat. The big size of vehicles need to avoid the low voltage, to use high voltage to reduce the cost and reduce the heat. In case it's accessible for the public because of the cost reduction, engineer and technician could access this kind of voltage, which is different from the bike and motorcycle, or even resistance spot welding. Nowadays, laser welding and ultrasonic is for large industry. This is SME. The accessible is the spot welding, which is low cost, but the performance would be lower than the laser and ultrasonic. This is the video shows how the spot works. I would recommend, if you choose the nickel to support, better find a slot. Otherwise, so this nickel negative electrode, if you don't choose the slot type, some electricity will share through the slot. So look at the hole that this one will decrease the electricity to connect. The voltage is about 3 volts. So it's not harmful if we touch it. So we need to check the capacity. What is the amp hour or watt hour? So it takes 1 hour to charge. So for one battery, it would take 2 hours. So it would take even longer if it's more battery. The battery pack, which required accuracy. So we need to use the self-discharge to check. We need to have a tool to check the level. It's not just ordinary meter. If we need to use specific tool for self-discharge, how do we use it? We need to charge all battery at the same level, or we need to leave it for 1 or 2 weeks, depends on the cell, to see the voltage. If it's too low, if it drops too low, we will not use that battery. Look at the pot graph. This is the resistance and the voltage. The fourth point is the best. The first one is the worst. If we have 2 groups, we need to separate them into 2 types. We need to check the quality should be similar. BEV combined. So this is the one battery pack. So this one, there are different battery pack. Some maker call BMU. BMS stand for Battery Management System. This system is to check the level of the cell and send this information to master BMS, which demand the system, the rhythm of the motor. If it's fully charged, it's communicate the charger station. It will distribute the electricity from external source. This also can detect the problems from the battery pack. Inside the battery pack called IMD, I will talk about it in the next slide. All information was sent to VCU or HMI to show the information for the driver. Dark green is the electronic components inside, like battery pack, motor, inverter. These components we cannot make, but it's the collaborations with the science technology organization. They are trying to make these components so that we can access and buy it. Battery management system need to have BMS. What do they do? So actually it works more than what I wrote. The electricity in the grid required BMS to keep it balanced, to check the temperature, power, electricity. Some type can turn on and off. Some call switch, some call. The circuit is protect the high voltage, high power. Depends on the design. This plays a significant role. BMS monitors voltage in different series. If the voltage has the same level, in case one cell BMS detect over voltage and control to decrease the voltage. HV box needs pre-switch inside because motor converter is act like short circuits. We need to install so we need to have separate main switch. So we need to turn on the pre-switch to charge all components. So we need to turn on the main contactor is to IMD in battery pack is to categorize minus and negative electrode. If it's low resistant, IMD will detect the information and send information to master BMS. Basically, it's the electricity protection.
What causes the battery to damage? So let's see. Here are the reasons what causes the battery to damage or explode easily. First of all, is the heat, or when the temperature is quite high, that will explode and causes the battery to burn quite easily. So how we go on about try to prevent this problem to happen? If you look at the video here, it's the explosion of the battery. Okay, so to prevent this problem to happen, first of all, we have to evaluate the temperature of the voltage to about 180 or 190 voltage. So to prevent this, there are different batteries. So we have to input the sensor by putting the voltage sensor and the temperature sensor. With the voltage sensor, it would help to detect all the pressure. Well, what important is we cannot use the water for this because it can cause the explosion. Here are the R136. You can look into the slide here that shows how to prevent the explosion of the battery. Well, for the standard temperature should be 20 to 40 Celsius, whereas it's very difficult in Thailand because Thailand are quite hot climate. There are different types of heat controller and temperature controller, so you will see the details in the slide provided. Okay, we should be able to give you, the participant, one question. Okay, I have a question. What happens if there's an explosion of the battery, which it should happen? This case happened before in the past with the battery explosion. What causes and what can prevent? How can we prevent this happen? Well, in order to prevent this, for example, 3 days ago, there's an explosion of the scooter. If it was me, I will use water to help. That's the first steps I would take. Maybe we can set up the nitrogen. Well, we might look into to set the tap water pipeline into the battery box. That might be able to help. Okay, so that can be applied to a mobile phone battery as well. The main is make sure that it's not connected with the cable. Okay, so the first step is to cool down the battery. Doing so, we can put the battery into water. That would help to discharge the power in the battery. So to sum up, we put the battery into the water in order to cool down the battery.